In this next section, we're going to look at a special type of relation called a function. For a relation to be a function, each value of x can only have one value of y. That's the idea. Okay? So, for example, if we looked at communities and where they are, that would be an example of a function because each community can only be in one territory. You can't have, oh, you can't have Winnipeg. Oh, Winnipeg's in Ontario and Manitoba. No, it's in one or the other. So that would make it a function. It's okay to have more than one value. Like you could have two cities be in the same province. That would still be a function because each x value, each city, can only have one y value. That's what makes something a function. There can't be more than one pair of coordinates that has the same value of x. A function is always a relation, but we can sometimes think of relations not being a function. So if we think back to our fruit and our color, if the fruit is our x value, bananas can be yellow and they can be green. So that makes it not a function because we have two y values for the same x value. Now generally in math, we're not going to be studying a lot about bananas and their colors. We're going to be dealing with more numbers, which makes sense. So here, is this a function or not? No, because we have one x value. The x value of 2 has two different y values. One x value of 2 has a y value of 3. Another x value of 2 has a y value of 5. So that makes it not a function. There are two coordinates having the same x value, but different y values. So each x value can have only one y value. No, it's not the other way around. There's a special name for each y value having only one x value. It's called a one-to-one function, but we're not studying that yet. Right now, we're just trying to determine if these are functions or not. Oh, I'll go back then. Is this a function? Yes. So what you're looking for are, do I have a repeat of my x values? If I don't have a repeat of my x values, it will always be a function. It doesn't matter that the 4 appears twice, because for something to be a function, each x value has one y value. The x value of 1 has one y value, it's 4. The x value of 3 has one y value, it's 4. There's not a second y value for x equals 3. Function or not? No. No. Why? The x value of -3 has two different y values. Okay, now right now, does this feel like we're doing something really abstract? Like I mean, it's like, why are we doing this? It's like, ooh, we're circling numbers and saying if something's a function or not. The idea of a function is very important for mathematics. Anytime you write an equation, y equals something else, you make a function. And so we're going to be, in mathematics, studying a bunch of different functions and how they relate to real life. And right now we're just developing the definitions for that. Ooh, arrow diagram. Is this a function? No. What's the problem? Which number is the problem? The 3. The 3 has 2 different y values. Some more definitions. You will use these definitions a lot from now until grade 12, finding out the domain and finding out the range. Now, the domain for any function or relation are all of the x values. So if you were trying to describe all of the x values that are possible, that would be your domain. The range are all of your y values. So when we tied our string with the knots were our domain, because those were our x values, and the length of our string, the different values of the length of our string, were our range. So give the domain and range for each of the following relations. Special notation. When we write domain, we like to write squiggle brackets like that. And we can list all of the x values. Can see our x values are 3, 1, 0, and -2. And it doesn't matter the order that you write them in. So some people really like to start with their smallest number and go to their biggest. Some people really like to just write it as they see it. It would be fine either way. Your range, your y values, well, we have the y value of 2 and the y value of 4. You don't need to rewrite them more than once, because those are the only y values you have. 2 and 4. Same for the domain as well. If you have something that appears more than once, you'd only need to put it once. I find in an arrow diagram it's really easy to see domain and range. What are our x values? 4 and 5. What are our y values? 7, 8, and 9. This one is not a function. Because the x value of 1 has 2 different y values. The x value of 4 has 2 different y values. And the x value of 9 only has 1 different y value. So the 9 is okay, but that's not a function as soon as there's an x value that has 2 different y values. But we can still say the domain of this relation is 1, 4, and 9. And the range of this relation is -3, -2, -1, 1, and 2. Part B. A relation associates a number with a prime factor of the number. So what this means is the number 4 can be divided by 2. The number 6 can be divided by 2. The number 6 can also be divided by 3. The number 8 can be divided by 2. That's the only prime number that divides 8. The number 9 can be divided by 3. That's the only prime number that divides 9. Is this a function? No, not a function. Which number is bad?
6.
The 6. But we can still say what the domain and the range. The domain is 4, 6, 8, and 9. And our range is 2 and 3. Oh, more French. Are you okay with that? Yeah. French months? How many days in the month? Is this a function? Yes, it is a function. Because each x value only has one arrow coming out of it. Even though there's two arrows that go to 31. This is going to mix you up. Can you see that mixing you up? The two arrows going to 31 makes you want to say not a function, but each x value is associated with only one y value. There's no x value that has two. So it is a function. If we wanted to write our domain, are you okay if I write it shorthand? Instead of writing out all the words. And what's our range? Okay. 20, I'm just kidding. What a waste of time to do it that way. 28, 30, and 31. In a workplace, a person's pay, P dollars, depends on the number of hours you work. Surprise, surprise. You work more hours, you get paid more. How much is this person getting paid an hour? $12 an hour. Might be just, what is minimum wage right now? $11.50. Nice. So, we've got the first value, those are your independent variables. Those are your x values. The second values are your y values. The table of values can make an ordered pair, which we've seen. These x values are your domain, and these values are your range. So we have one more example that we're going to look at. This table of values shows mass, m grams, of different numbers of identical marbles. Super exciting. So one marble weighs 1.27 grams. Two marbles, 2.54 grams. And so on. Why is this relation also a function? Each x value has only one y value. Which makes sense. You can't have three identical marbles all of a sudden weigh differently. You put them on the scale the first time and they weigh 3.81 grams. You take them off, put them on again, and now they weigh 6 grams. Wait a minute. Something's wrong. Okay? You might say that your scale has stopped functioning. It's not working. And that's where, when we say the word function, when something functions, it's supposed to do the same thing every time. And if it's not functioning, it's doing something different at different times, that wouldn't work. Especially in this case when you're weighing something. Now that's not to say that you should be the same weight every time you get onto a scale, because you might have changed in between. But for the marbles, they should be the same every single time. Identify the independent. The independent would be the number of marbles. And the dependent would be the mass. Give the domain and the range. The domain here is 1, 2, 3, 4, 5, 6. And our range, 1.27, 2.54, 3.81, 5.08, 6.35, and 7.62. Oh, this question is great for getting to know your 1.27 times table. Your 1.27 times table. 1.27 times 5, 6.35. Whew.